So standard 16, part A, asks us to find the convergence or divergence of this series from n equals 1 to infinity of root n over n squared plus 1. And so this series, you have to go through the convergence or divergence test to see which one fits best. And this series pretty obviously could not have been tested with the ratio test because the limit calculation resulting would have just not been, would have always been indeterminate, and L'Hopital's rule wouldn't have helped because the exponent of the 1/2 on top would just never have gone away. It would have been brought down, and then it would have been a negative exponent and would have kept going on forever. And the series is not geometric, so we couldn't use that test. And the divergence test wouldn't have worked either for the same reason the ratio test wouldn't have. The limit would not have been pretty. And the integral test would have been very painstaking as well. Compared to if you just look at this, root n over n squared, and just ignore the 1 for a moment, is the same as n to the 1/2 over n squared, which is equal to n to the 1/2 minus 2 power, which is n to the negative 3 over 2, which, as you can see here, is 1 over n to the 3 over 2. And so we could either do direct comparison or limit comparison of this given limit to 1 over n to the 3 over 2, because there's only a plus 1 added to the denominator here. We can't do direct comparison because limit as n goes to infinity of this function right here would be 0, and that's inconclusive in the direct comparison test. And so the limit comparison test, we take the limit of this function divided by this function of n as n goes to infinity to see the ratio of this series to this series as they approach infinity. And we got that to be limit as n goes to infinity of n squared over n squared plus 1, which is equal to 1 by L'Hopital's rule. And this number 1 is positive and finite, so by the limit comparison test, it behaves the same as this series right here, which is a p series, 1 over n to the p, and p equals 3 over 2, which is greater than 1. So by that p series test, this series converges. So therefore, this series, by the limit comparison test, behaves the same as this series, and thus it converges.